Hello and welcome to Technical Utkranti. With this video, we are starting with linked list. There are few important points to note here before we begin. Array was a simple and popular data structure that we have seen till now in this series. As a result, the awareness on the number of questions on arrays is more. And as a result, more difficult questions could be put for arrays. For other sophisticated data structures, the awareness on the number of questions is definitely lesser than that on arrays, and preparation for just popular questions on the sophisticated data structures should be a good start. In today's video, we'll firstly introduce linked list. Then we'll create a class in Python for linked list. In linked list questions, we'll be adopting OOPS approach because most of the platform where we do tests are in OOPS format only. So we'll get some idea of it. Let's first understand the basic differences between arrays and linked lists. If array, all the data in it is arranged in a sequential manner. For linked lists, it is a node which points to the next node, and this node points to the other node, and this node would point to another node. The first node of linked list is known as head, and the last node of the linked list is called tail. One major difference, as you see, this is a continuous chunk of memory, whereas linked list is a collection of nodes which are not together in the memory. Alright. Now, one advantage of arrays is that accessing elements is quicker, better. How? I can write array of 5 and I can directly access the element at the 5th index. Over here, if I have to access the 5th element, I have to start from head and then go on till the 5th element, and then only I'll access it. So accessing is a bit slow. In arrays, deletion of elements or insertion of elements is a bit costlier process. For example, if this element has to be deleted, then in order to maintain the continuity of memory, all the elements subsequent to the deleted elements have to be shifted. So this is a time consuming process. Whereas if I have to delete or insert any element in the linked list, then basically, let's say I have to delete this element, then what I have to do is I just need to modify the linkage to point to the subsequent element, and this particular node is automatically gone. So modification is quicker in linked lists as compared to arrays. So I hope you got some basic picture of difference between arrays and linked list. Before starting with the questions, let's begin designing the class for the linked list. In this class itself, we'll be writing the method for the solution of the question. As we have seen right now, that linked list is a collection of nodes where each node points to the next node. So we'll create one class for the creation of node and one class for the creation of linked list. The init function, which you see here, gets called when the class is called to create the node. The object of the class node will have two members, which is the value, the data itself, and the pointer to the next node of the linked list. This way I create the class node. Now I create another class called linked list. This will have its init function of its own. The init function is called when the object of the class is created. So this init function is called automatically. For a linked list, we'll have a head and tail, and to begin with, the head and tail of the linked list are initialized to none, indicating that currently there is no element in the linked list. We'll have one more function which is iter function, and this is also of the same type as the init function over here. This iter function is executed when the object of the class linked list is accessed using a for loop. So this function will be used to print the linked list. The functions with the above underscore underscore notation are called magic functions. As you can see, this iter function, init function, and init function of the node class are having a specific notation. They are not called directly but are executed in an indirect way. For example, underscore underscore init function is executed when the object of the class is created. Similarly, underscore underscore iter underscore underscore function is executed when the object of the class is accessed using a for loop. We'll also see the insert function. How are the node inserted? For that, we'll quickly see how the objects are created. So I'll have a linked list created like this. So just by this instruction, my object of class linked list is created. Now linked list will have a head and a tail, and both initialized to none, as you can see over here. After creating the linked list object, I'll insert a node. So I'll pass on a value 5. What will happen when I pass 5 is the resource over here gets the value of 5. With that, the node object is created. So that was the purpose of having node class. Firstly, a node with the value of 5 is created. Then, once node is created, we need to traverse till the end of the linked list in order to insert the node at the end of the linked list. When we begin, we have both head and tail as none. It means that there is no node currently inside the linked list. In that case, we'll have starting node as none, and therefore we will assign head to the node. All right. If there are some nodes already present in the linked list, then we need to traverse till the end of the linked list, which is done by these two lines of code. And then at the end, we'll assign the node that we have created right now. Finally, the tail of the linked list is assigned to node because node is the last node of the linked list. I hope the insert function was clear to you. So let's begin understanding the question. What is the first question of the linked list? It is reversing a linked list. For example, you are given an input as 1, 2, 3, 4, 5, which is a linked list. You have to reverse it such that it becomes 5, 4, 3, 2, 1. In this linked list, 1 is the head, 5 is the tail, and the last node points to none. So when a node points to none in the linked list, it is the indication that the linked list is finished. When the linked list is traversed, it starts from head and then it jumps from this node to the next node, then this node to this node, from this node to the next node over here, from this node to the next node over here, and once it encounters the none, which means that the linked list is finished. In order to reverse this linked list, we need to do two things. We need to swap the head and tail. 1, 2, 3, 4, 5. We need to reverse or swap the head and tail, and then reverse the linkages. And of course, the first element should be pointing to none. So this is the thing that we need to do. Now, what is the approach? We start from head, and let's say this is called the current node. For the first node, there will be no previous node. This is the indication that it should point to none and it should be tail. Alright. Now, before reversing this link over here, we need to note down the next node. This is important. For the next iteration, current node becomes the previous node and next node becomes the current. Now, from this current node, we will note down the next node because we have this link available over here, and then we'll be reversing this link. So this was gone previously only, and once I reverse this link is gone. But I've already noted down the next node. For the next iteration, current node becomes previous node and next node becomes the current node. So from current node, I will note down the next node. I'll reverse the link for current node pointing to the previous node, and then current node becomes previous node and next node becomes the current node. Then I'll note down the next node value because, as you know, this link is still available. Then break this link and make current node point to the previous node, and then current node becomes the previous node and next node becomes the current. Similarly, I'll note down the next node, break this link, create this link, and current node becomes previous node and next node becomes current node. When current node is none, we'll stop this operation, and then previous node is used to assign the value of head. So head becomes previous node. In this way, we get this particular linked list. Let's write down this pseudocode for it. To begin with, we'll start with the head, and then we'll continue until the current node is not none. The first thing we have to note is the next node. So this is the next node. Then for the first node, there is a special operation. So we'll see if the current node is the head node, then tail is the current node. So we are making the first node as tail, and we are assigning the next of the current node to none. Alright. Otherwise, what we'll do is we will be pointing to the previous node. Then we'll make current node equals to previous node and current node as next node. Alright. So this will go on. Let's quickly see the Python implementation of it. I begin with the head. If the linked list is completely empty, then no operations could be done. We'll just return. Otherwise, we will firstly find the next node before breaking or changing any linkages. Then for the first node, we'll assign the tail, and its next, the next of the first node is none. In other cases, we'll have a previous node, right? Previous node becomes the current node, and the next node becomes the current node. At the end, whatever is the value of the previous node, that becomes the head. Let's see if our implementation works fine. I'll create linked list to have 1 to 5. Now let's see how the linked list looks like. So dot value for node in. So this is the object of class linked list, and when I am accessing it using for loop, then the iter function that we have written previously gets activated. Okay, let's see how the linked list looks like. So we have 1, 2, 3, 4, 5. Now we will call the reverse function of the object of the linked list class. So this should reverse the linked list for us, and then again we'll print the linked list. So as you can see, our linked list is reversed. So I hope you found some value out of this big video, and thank you. Bye bye. Good night.